Black holes are the total rock stars of space. They're not just strong, they're capable of smashing entire stars into bits, tinier than atoms. And here's the kicker. They might even have the super-duper power to erase the whole universe. Mind-blowing, right? Come join us as we're about to dive straight into the heart of the action, exploring the crazy, mind-bending world of black holes and how they can influence the fundamental nature of any information. These things break all the rules of how we usually think about space. It's like entering a mysterious realm where normal doesn't exist. Let's start this cool adventure. So what exactly is a black hole? Imagine a superhero of space, born when an immense amount of matter huddles together in the tiniest space possible. At the core of a black hole, gravity becomes an unstoppable force, tearing anything that ventures too close into its fundamental building blocks. Even light, the fastest thing in the universe, cannot escape their gravitational grip. Hence, we perceive black holes as these eerie, all-consuming spheres of darkness. To put it simply, let's compare a black hole with a river. Imagine you're floating in a river that gradually picks up speed. You're blissfully unaware until you reach the point of no return. That is what we call the event horizon. Now, imagine the outer border of a black hole, analogous to the edge of a colossal waterfall. Once you pass this boundary, there's no swimming back to safety. You're irresistibly pulled towards a certain doom, a black hole waterfall. Intriguingly, this boundary effectively separates black holes from the rest of the universe, a one-way trip with no chance of return. While the interior of black holes may remain a mystery, scientists have some clues about what happens at their edges. Black holes are like a pot of boiling water, losing steam and emitting Hawking radiation, causing them to slowly lose mass. For instance, a black hole with the mass of our Sun would take an unimaginable 10,000 quadrillion years to shed a minuscule one in a billionth percent of its weight. This process continues, speeding up over time, until these cosmic behemoths evaporate into nothingness, leaving behind only a faint trace of radiation. Now let's talk about information, the essence of diversity in the universe. Everything, from a hot air balloon to a sports car, is composed of the same basic building blocks. It's the arrangement of these atoms that creates the rich tapestry of the cosmos. According to the theory of quantum mechanics, information is indestructible. It might change forms, but it can never truly vanish. Consider burning your personal diary with all your favorite memories. You get ash, and that ash will never revert to the same diary. However, if you meticulously collect every carbon atom from the ash and analyze the smoke and heat properties, you could theoretically reconstruct the diary. The information in the diary persists somewhere in the universe, albeit in a more challenging form. Now enter black holes, disrupting the cosmic status quo. Information is our key to understanding reality, providing absolutes in a relative world. Black holes, however, defy this principle. They destroy information, creating a perplexing paradox. How could something so fundamental to our laws of physics be lost? The quest to solve the information paradox leads us to intriguing possibilities. One option suggests information is lost forever, prompting a rewrite of the laws of physics, a daunting but exhilarating prospect. Another proposes that information is hidden, perhaps forming a new universe inaccessible to us, akin to having your dear one's photos on a broken hard drive. Yet there's a third, more optimistic option. Information is not lost or hidden, it's just stored differently. Enter the concept of cosmic housekeeping with a twist. Picture a black hole as a cosmic tunnel filled with as many planets as possible. As we toss in more planets, the tunnel, despite reaching maximum capacity, dynamically expands to make room for new information. In essence, a black hole grows its surface area, encoding information on its boundary. This peculiar solution, known as the holographic principle, suggests that information is stored on the surface of black holes. Even the smallest black hole, acting as the ultimate hard drive, can store more information than all the data produced in human history. It's like transforming a library into an e-reader, with the content encoded and memorized differently. If information is imprinted on the boundary of a black hole, the Hawking radiation emitted during its evaporation could carry this information away. This resolves the information paradox and eliminates the need to overhaul our understanding of physics. However, it demands a fundamental shift in our comprehension of reality. Imagine everything that falls into a black hole being stored on its event horizon, a flat surface. This seemingly counterintuitive idea leads us to the concept of a hologram. Just like a 3D photo encoded on a flat piece of plastic, a black hole acts as a cosmic hologram. A person inside a black hole experiences a normal three-dimensional life, but for external observers, they become flattened images on the surface of the black hole. Now let's take a leap of imagination. If this duality between 2D and 3D works for black holes, could it apply to the entire universe, including us? If we were inside a black hole, unaware of our flat encoding, we might share the same fate, stretched over a cosmic flat screen at the end of the universe. The science behind these concepts delves into the bizarre realms of toy universes, string theory, and intricate mathematics. While we grapple with the complexities, one thing is certain: the universe is far stranger and more intricate than we ever imagined. Black holes, with their mysterious properties, might hold the key to understanding the very nature of reality. In conclusion, our exploration into the captivating world of black holes has taken us on a journey from cosmic waterfalls and event horizons to planet-filled rooms and holographic principles. As we stand at the threshold of understanding the universe's secrets, one question lingers: could black holes truly unlock the mysteries of reality itself? Embark on this extended cosmic adventure with me. If you yearn for more tales from the universe, or wish to share your cosmic thoughts, comment below or hit the like button. Let our cosmic journey continue, unfurling new chapters in the cosmic narrative.